Okay, guys, so we're moving on to our next section, section 12.3, surface area of circular solids. Now, I want us to take a minute and do the do now. Remember, when we're finding the surface area of something, this is the first time I'm actually putting two different figures together for you. So when we're finding the surface area of something, think everything we can get to without dismantling the figure. So we want to find the surface area of this house. Now, this is a little toy house. So let's just talk about what we're painting. Obviously, we're painting all the outside rectangles of this house. We could take this house, turn it over, and paint that bottom of the house. Now on top, we have 1, 2, 3, 4 triangles that we can paint. Now, why am I not able to paint this last square over here? The reason we're not able to paint that last square is in order to paint that last square, we'd have to chop off the roof of this house. And remember, surface area is everything you can easily paint without dismantling the figure. All right, so now that we have our game plan, let's get started. So we want to find, now I know this is a regular square pyramid because this is bottom is a cube. All sides, length, width, height are all 5. The side of the triangle is 5. So this is awesome. This is a regular square pyramid. It is a cube base. We are doing awesome. So let's find the area of, let's see, 1, 2, 3, 4, 5 squares. Area of 5 squares that are all congruent. So we're 5 times 5 squared. So we are 5 times 25, which is 125. Plus the area, because this is a regular square pyramid, all these triangles are congruent. Not only are they congruent, these triangles are equilateral. So how do you find the area of an equilateral triangle? If you remember, and we're going to do 4 times the area of an equilateral triangle. So 4 times, remember, it's side squared over 4 root 3. These 4's cancel, so we are just at 25 root 3. So our surface area is 125 plus 25 root 3. Okay, area of a cylinder. So when we're talking about a cylinder, find the area of a cylinder, I have a very cute thing, trick for you to try to remember it. Now a cylinder, look here, what is this little munchkin holding? He's holding a diploma. He just graduated, but he did not just graduate kindergarten. He didn't graduate middle school. He didn't graduate high school. He didn't even graduate his undergrad. This little munchkin is a genius and just learned his PhD. So to find the lateral area of a cylinder, my shortcut for you to remember is PhD. What does that mean? What does that represent? Lateral area of a cylinder is P for pi, H for height, D for diameter. Now the total area is going to be the lateral area plus the area of the base. But this time we don't just have one base, we have 2 bases. So lateral area plus the area, I should say plus 2 times the area of the base. So let's do a problem. Find the lateral area and the total surface area of a cylinder with a radius of 5 centimeters and a height of 6 centimeters. Okay, so let's see what we have. So the radius is 5 and the height is 6. So the lateral area is PhD, pi, height, diameter. Pi is pi, height is 6, diameter is not 5, the radius is 5, so the diameter is 10. So the lateral area is going to be 60 pi centimeters squared. Now the total area is going to be the lateral area plus 2 times the area of the base. Well, the lateral area we know is 60 pi, and we're going to do 2 times pi r squared because it's a circle. So we are 60 pi plus 2 times pi 5 squared. So we are 60 pi plus 50 pi, which gives us 110 pi units squared. Okay, let's look into another one. Okay, so the next one we're going to talk about is a cone. And my cute little way for you to remember the lateral area of a cone is, as everyone always says shell, some people say horizon. No, but inside the shell is a pearl. But this pearl is spelled differently. It's spelled pi-r-l. So to find the lateral area of a cone, it's pi-r-l pearl. Now this L, this little script L, represents something very different. This little script L represents slant height. Now, a slant height of a cone, we know this is the radius, this is the altitude. Now, the slant height is basically this part right here. It's like the hypotenuse of the right triangle made between the altitude and the radius. That's our slant height. Now, the total area is going to be the lateral area plus the area of a base. And there's only one base. So find the total surface area of a cone with a radius of 5 and a slant height of 6. So here we go. Here's our cone. It's saying our radius is 5 and our slant height is 6. So the total area is going to be the lateral area plus the area of a base. To find the lateral area, it is pearl pi rl plus pi r squared. So we're pi, our radius is 5, our slant height is 6, plus pi 5 squared. So we are 30 pi plus 25 pi, which is going to give us 55 pi units squared. Oh, not units, feet squared. There we go. All right, next one is a sphere. Okay, to find the total area of the sphere, no cute way to remember this, it's just going to be 4 pi r squared. Now there's only total area here because there is no base for a sphere. Okay, there is no base for a sphere, so total area is going to be 4 pi r squared. Now, I'm going to add one more thing here. Let's find the lateral area of a hemisphere and the total area of a hemisphere. So now, why is there a lateral area and a total area of a hemisphere? Let's think about what a hemisphere is. A hemisphere is a sphere cut in half, right? You have your northern hemisphere, southern hemisphere. It's a sphere cut in half. So when you cut that sphere in half, look what we've just created. We've just created a base. So to find the lateral area of the hemisphere, it's going to be everything that's not the base. So the way we do that, it's going to be the total area divided by 2. Doesn't that make sense? Total area divided by 2. So that's going to be 2 pi r squared. So the lateral area is going to be 2 pi r squared. Now the total area is going to be the lateral area plus the area of a base. So the lateral area is 2 pi r squared plus the area of the base, which is just 1 more pi r squared. So the total area is 3 pi r squared. That will come in handy. All right. Find the total surface area of a hemisphere with a radius of 6 feet. So total area, so a total area of a hemisphere is 3 pi r squared. So we're 3 pi 6 squared. So we're 3 pi 36, which is going to be 108 pi feet squared. Okay, so now let's start putting some shapes together. Find the total surface area of an ice cream cone with a radius of 12 and a height of 9. So let's get this. Let's think of some shapes we're going to have. So our the bottom of the ice cream cone is obviously a cone. Now it says the total surface area of an ice cream cone. So remember, it's just what we're able to paint. So here's our cone, and now here's our scoop of ice cream. How do we paint this? This is a toy, it's all linked together. So we can paint the lateral area of the cone, everything we can paint without dismantling the figure. I know it says total surface area. I know what it says, find the total surface area. But now once we start putting shapes together, total surface area is just everything you can possibly paint without dismantling the figure. It does not mean to dismantle and paint the bases. I'm going to say this again. I know it says total surface area, but now once we start putting different figures together, when it says total surface area, it's everything we can paint without dismantling the figure. So we can paint the lateral area of the cone, and we can paint the top of this ice cream, but the top of the ice cream is not a total sphere. It's the lateral area of a hemisphere. So the lateral area of a cone is curl, pi r l, plus the lateral area of a hemisphere is 2 pi r squared. And it says the radius is 12, a height of 9, okay, so we need the slant height. So this is a triple, 9, 12, 15. We know our radius, so we're pi 12, 15 plus 2 pi 12 squared. If you simplify all of that, we are going to get 468 pi centimeters squared. Find the lateral area and the total surface area of a cylinder that has a diameter of 16 meters and a height of 2 meters. Okay, I want you to do that by yourself. So lateral area, you can pause me. Lateral area of a cylinder is PhD, pi, height, diameter. And the total area of a cylinder is going to be the lateral area plus 2 times the area of the base. So we are PhD plus 2 times pi r squared. When you do that, you're going to get the lateral area to be 32 pi. And you're going to get the total area to be 160 pi. Okay, next problem. Okay, find the surface area of the washer. All right, so we will definitely be dealing with things a little bit more complicated like this. So when we find the surface area of the washer, basically, I want to do everything we can paint without dismantling the figure. So let's just come up with the game plan of what we're actually going to paint. So we have 1, 2, 3 rectangles, but it doesn't stop there. 4, 5, 6, right? We could turn this around. So we're going to find the area of 6 rectangles that are all congruent plus. Now we have the top, and then we could flip it over and paint the bottom. So let's see what the top is. The top is 1, 2, 3, 4, 5, 6 sides. Now I'm thinking just two-dimensional. It's a hexagon, but there's something cut out of it. Just think two-dimensional, the circle. So we're going to say the area of the hexagon minus the area of the circle. But that's the top, and if you flip it over, it's also the same thing on the bottom. So I'm going to multiply that by 2. Okay. Now you might think that's done, but can't we also get a little skinny brush? And because remember, we're thinking three-dimensional, this figure is a three-dimensional shape. So there's some depth there. So that's not a circle. It's a circle that now has been pulled longer. So that is the lateral area of a cylinder. So this is our game plan. So we want to find the area of the rectangles. Well, that's going to be pretty easy. That's just going to be 6 rectangles. So I should have written this differently so it makes more sense to you. I should have done 6 times the area of a rectangle, just like we did for the other one. All right, so we're 6 times 8 times 2. So that's going to be 96. Now this is the hard part, the area of the hexagon. Now remember, this is a regular figure with a side length of 8. And because it's regular, it's going to be half the apothem times the perimeter. So remember how we figure out the area of regular polygons. We draw in all radii to the vertices. And that means each central angle is going to be 360 divided by 6, which is 60, 60, 60, 60. We're going to drop down that altitude. When we drop down that altitude, that 8 will get split into 2 4s, and we have a 30, 60, 90. So the apothem will be 4 root 3. So now the area of the hexagon is going to be half the apothem times the perimeter. So we're half 4 root 3, and the perimeter is 48. Half of 4 is 2. 2 root 3 times 48 is 96 root 3. So we're going to do 2 times 96 root 3 minus the area of the circle. Well, it says here the radius is 2, right? Since the radius is 2, we're just going to do pi r squared. So that's going to be 4 pi. Distribute that 2 in. We're going to have 192 root 3 minus 4 pi. Now we want to find the lateral area of a cylinder. Well, the lateral area of the cylinder is PhD, right? Pi, height, diameter, the little diploma. So pi is pi. Height of the cylinder is the same as the height of the washer, which is 2. And the diameter, if the radius is 2, the diameter is 4. So we are plus 8 pi. Oops, I think I messed up the area of the circle. The radius is 2, so pi r squared, sorry, backtrack, pi r squared is 4 pi. That's why we got to write everything down. So then when you distribute that 2, that would be an 8 pi. There we go. So now we're going to simplify what we can. I have a negative 8 pi and a positive 8 pi. That cancels right out. So we are 96 minus 192 root 3. And that is our total surface area. All right, on the next page, I know this says independent, but I actually want to do these with you because they're problems you need to know. So find the surface area of the following figures. So we have a half cone. So remember, surface area, when we have different types of things going on, it's everything we can paint, right? It's everything we can paint without dismantling the figure. So this cone looks like it has been cut in half. So what are we going to do? Once this cone was cut in half, we could do half the lateral area. So that will paint this outside. Plus the area, now we have this triangle, so plus the area of a triangle, plus now we could flip it over and paint the bottom, but the bottom's not a whole circle. It's going to be half of a circle or a semicircle, right? So lateral area of cone. So half, to find the lateral area of a cone, is going to be Pearl pi r l. Pi is pi. Our radius is 5, and our L is at 13. So this is going to be 45 over 2 pi. Oh, that's 45, that's 65, sorry. 65 over 2 pi. Now we want the area of a triangle. Area of triangle is half base times height. So we are half, our base is 10. And we need to find the height. The way we're going to find the height, we're going to be a little bit strategic here. So we're going to make a right triangle right there. Our hypotenuse is 13. Our radius is 5. So it's a 5, 12, 13 triple. There you go right there. So now we're going to be, our base is 10. Our height is 12. Half of 12 is 6. So we are plus 60. And then we want to find half the area of the circle. So that's going to be pi r squared over 2. So we are going to be plus 25 pi over 2. And then we have 65 plus 25. 65 pi plus 25 pi is 90 pi over 2 plus 60. So that's going to give us 45 pi plus 60. And that is our final answer here. All right, 2 more problems. Okay, the slice of cake. This is also going to be a little bit sneaky. So think of what we got going on here. Everything we can paint without dismantling the figure. So we have a rectangle in the front, a rectangle, sorry, on the 2 sides, right? A rectangle here, rectangle here. So we're going to say area of a rectangle times 2 plus, now the top, isn't that a sector? And isn't there also a matching sector on the bottom? So we're 2 times the area of a sector. Now here's the hard part. This is not a rectangle, this is curved. So this is the fractional part of a cylinder. So plus fractional part of cylinder. And we'll get to that in a minute. So 2 times the area of a rectangle. So we're 2 times 6 times 10, which is going to be 120. And now plus 2 times the area of a sector, that's going to be arc over 360 times pi r squared. So we are going to be, our arc, the central angle is 90, our arc is 90. So we're going to say 90 over 360 times pi r squared. So that's going to be 120 plus 1/4. This simplifies down to 1/4 times 2. So we're going to be 2 pi 6 squared, which is going to be 1/4. That 2 got canceled because we went down to 1/4. Hold on, backtrack my algebra. Skipping ahead too much. So this was going to be 2 times 1/4 pi 6 squared. There we go. So this gets down to 2.5. There we go. So now we are 36 divided by 2 is 18. So we are 120 plus 18 pi. Still not done. So now the fractional part of the cylinder. To find the fractional part of the cylinder, you're going to take whatever degree that arc is from the sector and put it over 360 times the lateral area, which is PhD. So in this scenario, we were down to 1/4 pi. Our height is 10. Our diameter is 12. 1/4 of 12 is 3, so we are plus 30 pi. So we are 120 plus 48 pi. All right, last problem. Okay, paper towel roll. We got a lot going on here. So let's think of what we have. So we're going to paint the top and the bottom. To paint the top and the bottom, it's going to be the area of a big circle minus the area of the small circle times 2, because that's the top and bottom, plus the lateral area of the cylinder, and I'm going to say big cylinder, plus, you know what, I need much more space here. Okay, so we said area 2 times area of the big circle minus the area of the small circle plus lateral area of the big cylinder. But we're not done. Why are we not done? Can I take a little skinny paintbrush and just paint that inside of that paper towel roll, right? So we're going to say plus the lateral area of the small cylinder. All right, let's get working. So we got 2 times pi, the big radius is 8. So pi 8 squared minus pi, the small radius, which is 3. So pi 3 squared. So that's going to be 2 times 64 pi minus 9 pi, which is going to be 55 pi times 2 is 110 pi. Now let's find the lateral area of the big cylinder, which is PhD. So pi, our height of the cylinder is 20. And our diameter of the big cylinder is 8 times 2, which is 16. This is going to be plus 20 times 16 is 320 pi. Now the lateral area of the small cylinder is going to be PhD again, but a different diameter. So we're pi, our height is still 20. This time our diameter is not 16, it's going to be 3 times 2, which is 6. So that's going to be plus 120 pi. So our total area is going to be 550 pi units squared. All right, guys and girls, we are finally done for today. We'll talk to you again soon.